Hello everyone! In my previous video I showed you a custom phone home sketch for my ESP32. When the ESP powers on, it connects to the Wi-Fi network and makes contact with a small Python server, telling it its name and IP address every 10 minutes. Then, when I contact the server, it shows me the device name, IP and timestamp. I also have a bigger project. That is a graphical user interface for those same ESP devices. With that GUI, we can easily set up Wi-Fi and do some basic I/O functions. Today, I want to integrate the phone home code into the GUI code. But how do we do such a thing? Well, both projects have sort of the same structure. So the phone home code is cut into pieces and inserted into the right places on the GUI project. Also, some hard-coded parameters will be reworked into the GUI's config page and other support routines. Finally, some code needs to be removed, which was an earlier attempt at device discoverability. Next, I will show you the code in a so-called div tool. It shows the final GUI code and highlights the parts that were added or removed. Well, here we go. I commented out a header file that is no longer in use. Some comments were added. These were constants in the phone home code, but now they are variables, so they can be modified by the user. We have two objects for talking to web servers, one for HTTP and another for HTTPS. This project does a lot of debugging to serial, so I added the new variables also. I have renamed the web pages for the Wi-Fi config to just config. In the main loop, I added the phone home main loop function call. The big empty space here is where some old keep alive code was removed. These here are some helper functions. This one loads the configuration from EEPROM. So I added the new variables here. And there obviously also is a function for writing the variables to EEPROM. The web pages returned by the ESP are all embedded into the main files as define statements. I do not want to be dependent on external files. One of these web pages is the config page. You can see how the new variables are integrated here. Remember that phone home function call in the main loop? That call goes here. There is some timekeeping going on, so we run the code every 10 minutes. And then we either do a secure HTTPS web requests or one by HTTP. This is a helper function for doing the web request. Now follows a lot of unchanged code, mainly for handling web pages. Two of those pages are extended for handling and saving the new variables. Here's a call to that save all config function we saw earlier. And that is it. We reached the end of all the modifications. Now I want to give you a demonstration of what the final code can do now. This window here is the serial monitor, so we can see all the things the ESP wants to share with us. First thing to notice is how all the configuration is empty after reading from EEPROM. And without that configuration, it cannot join any Wi-Fi network. So it decides to set up its own hotspot, so we can join it. Let's do so. Then we take this IP address and go there with a browser. I give this device a name and the credentials of my lab's Wi-Fi network. The ESP reports what it has received from the browser and what was written to EEPROM. Again, we reboot. I really need to add a reboot button. And the connection is successful. And we got a new IP address. The hotspot has also disappeared. Check. Going to that new IP address, we can now configure the phone home settings. First, a secret key to keep your stuff to yourself. Just type anything that is not easy to guess. And then the server details. You can either copy these and use my public demo server, or set up your own using the Python code in the description. Eat, sleep, rave, repeat, was it not? Or something similar? And phone home was successful. Let's visit the server. And enter that secret token. And there it is, a list with all my devices, or in my case, the same device with different names. Let's click on the last one. And it got me right to the device. How cool! Now we can do the usual stuff for testing. If we want to go a step further, we can look at the actual URLs called on the ESP itself. Combined with the IP, we can make a URL to set the pin directly outside of the GUI, maybe even from script. Thank you for watching.